Hello class, good evening to all of you. I welcome you all to today's session, which is Kickstart your class 9th math preparation with polynomials. Got it? So, good evening to all of you. And so, since the topic is Kickstart your preparation with polynomials, this webinar will be covering the basics of polynomials. So those who have doubts in the basics or those who are still confused with some terms or the others, I recommend all of you to sit throughout this webinar and all your doubts will be solved. Got it? That is my assurance to you. All your doubts will be solved. Understood? So since because see, I have heard many of the students, sir, what is polynomial? Whenever I'll say polynomial, sir, what is polynomial? That is the first thing they will ask. Understood? So this webinar will be covering the basic part of the polynomial. Got it? So I hope all of you will enjoy this webinar. Okay, so let's start. So before I start my this webinar, let us briefly introduce myself to you. My name is Gopal Paliwal. Okay, I am a graduate from IIT Dhanbad. Okay, and I have done the teaching for I'm doing the teaching for last 2 years. I have taught and mentored around 1,000 students, and I have worked in the content development as well as I have taught and mentored the students in the field of IMO as well as NTSC. Understood? So let us start the topic. What is polynomials? That is the first thing we have. Correct. Now we don't know, sir, what is polynomials, why it is not called algebraic expression, what is the difference between them. Understood? So that part will clear today. So we say polynomials. What are polynomials? Polynomials are algebraic expressions. Remember, polynomials are algebraic expressions. We are not saying this, but the condition is having one or more terms. Okay, there should be one or more terms. Got it? Where power of all the variables is a non-negative integer. Non-negative integer, in other word, we can say is what? Whole number. So power of the variable should be what? A whole number. Now, so what I told you, remember this thing that suppose 1 is a natural number, correct? 2 is a natural number. These are all 1, 2 and so on. They comes under the category of what? Natural number. If I add 0 as well, then this whole will become what? Whole number. Then if I add the negative of these numbers as well, then the whole set will become integers. Remember this thing? Okay, this we have already studied in the first chapter. Similarly, see, we have polynomials. Okay, and then we have algebraic expression as well. So suppose this whole set, this whole thing is what? Algebraic expression. This whole thing is what? Algebraic expressions. In that algebraic expressions, only some of it will be polynomials. Which of these algebraic expressions will be the polynomials? Where the power of the variables, whatever variables you are using, that power has to be a non-negative integer. That means whole number. So if I say x square, so in this my variable x is my variable. This all of you know what are variable, what are constant, what are coefficients of the variable. That has already been covered in your previous grades. Got it? So x is your variable. Now the power of the x here is what? 2. So I will say okay, this will be a polynomial. Understood? If you ask me, sir, is it an algebraic expression? Yes, all the polynomials will be algebraic expression. It is an algebraic expression as well. Got it? But suppose if I ask you x square raised to the power 5, x raised to the power 5 by 2. Now if I ask you, is it a polynomial? So you will say, sir, what is the power of the variable here? 5 by 2. Is 5 by 2 an integer? Is 5 by 2 an integer? No, it is not an integer. So I will say, sir, it is not a polynomial. It is not a polynomial. But if you ask me, sir, is it an algebraic expression? I'll say yes, it is an algebraic expression. Understood? It is an algebraic expression. So anything with variable, if you got variable anywhere, you got variable in a whole expression, if there is any variable or anything, it will be called an algebraic expression. It will be called an algebraic expressions. But all the algebraic expressions will be polynomials, that we cannot say. So for that, what is the condition? There is only this one condition, that is what? Power of all the variables should be a non-negative integer. Or non-negative integer means what? Whole number. So whenever an expression, algebraic expression is written, just check the powers of the variable. If all the powers of the variable are whole number, we will say it is a polynomial. Understood? I hope I am clear at this point. So this is the basic difference between algebraic expressions and polynomials. Understood? Now, so we have done that these are the polynomials. For example, 3x square plus 5x plus 7. Now see, here 3x square, what is the power of variable here? 2. What is the power of variable here? 1. What is the power of the variable here? What is the power of the variable in this term? You will say, sir, there is no variable. What should we do? Understood? There is no variable. What should we do? So what I'll say, okay, if you say there is no variable, so I can write this 7 as 7 into 1. Can I write 7 as 7 into 1 or not? Yes, I can write it. If I can write the 7 into 1, so this one, we know this thing, that anything raised to the power 0 will be equal to what? 1. Anything raised to the power 0 will be equal to what? 1. We know this thing. Yeah. So I can say, sir, this one I've got now. So I'll say it is something raised to the power 0. Yes or no? Now this something raised to the power 0 could be anything. If I write 2 raised to the power 0, then also it will be 1. If I write 3 raised to the power 0, then also it will be 1. If I write, say, Hathi, Goda, anything, Hathi raised to the power 0, then also it will be 1. Got it? So here I can write x also. X raised to the power 0 will also be equal to what? 1. So I'll say this can be written as 7 into x raised to the power 0. So what we understood here, what we learned here, we learned that when the number is written, there is a hidden variable which is written as x raised to the power 0. As x raised to the power 0 will be 1, and 1 will not change the value upon multiplication. So what is the power of the variable here? Power of the variable here is 0. So now let us check what we have told. Any algebraic expression in which power of all the variables in all the terms is a non-negative integer or a whole number, we will say it will be a polynomial. So 2 is a whole number, yes. 1 is a whole number, yes. 0 is a whole number, yes. So it will be a polynomial. This is a polynomial. Quite simple, quite easy, correct? Clear? I hope I have cleared it. Got it? Remember this thing, when the number is there, we will say in that x raised to the power 0 is multiplied. Anything raised to the power 0 is equal to 1. So I'll say 7 into 1, and this one I can write as x raised to the power 0. Got it? So powers of x are 2, 1 and 0. So we will say it is a polynomial. Quite simple, class. Clear? Then 4x minus 9. Again, let us check the same way. What is the power of the variable here? 1. What is the power of the variable here? Sir, 9 I can write as 9 into 1, which can be written as 9 into x raised to the power 0. So it will be 0. So power of the variables, a whole number, yes. Is it a whole number? Yes. So I'll say this is also a polynomial. Correct? This is also what? A polynomial. Clear? Clear? So I hope you have understood. See, it's very easy. Just any expression they have given, just check whether the power of the variable is a whole number or not. If it is whole number in all the terms, I'm not saying only one term, throughout that whole expression, everywhere the power of the variable should be a whole number. It could be 100, 1000, anything, but it cannot be negative. Understood? It cannot be negative. Then it will become a polynomial. Clear? So now see, in this part, just for the reference, x in this equation, x is called what? Variable. this 3 and 5, they are called, 3 is coefficient of x square and 5 is coefficient of x. 3 is coefficient of x square and 5 is coefficient of x. This 7 is called constant term. This 7 is called constant term. So similarly, if I ask you here in this 4x minus 9, which one will be the constant term? So we will say, sir, minus 9 is constant term. Remember class, we are not saying 9 is constant term. No, minus 9 is constant term. Remember this thing. The sign of that number is carried. Okay, the sign of that number is carried along with it. So if I ask what is the coefficient of x here, you will say, sir, coefficient of x is 4. In this 4x minus 9, if I ask you, tell me student, what is coefficient of x square? You tell me, sir, what you are asking, sir? There is no x square. Why you are asking the power of x square? I'll say, see, 4x minus 9, you have written like this. I can say, okay, if I'm asking you coefficient of x square, you can write 0 into x square. What is the problem there? 0 into x square, correct? 0 into x square you can write. 0 into x square. So I'll say whatever other terms of x square are, they are multiplied with what? 0. So the coefficient of x square in 4x minus 9 will be equal to what? 0. Understood? Understood? Clear? So if I ask you what is the coefficient of x cube in this, so you will say coefficient of x cube is what? 0. What is the coefficient of x raised to the power 5 in this? Coefficient of x to the power 5 is 0. The terms which are not there, that means they are multiplied by 0. That is why we cannot see them. Clear? It's quite easy. Understood? But if I ask you, suppose if I give you an algebraic expression, let us say x square minus 3x plus 5. So if I ask you what is the constant term in this, so you will tell me, sir, constant term in this will be plus 5. Okay, so this is my constant term. If I ask you what is the coefficient of x square, so coefficient of x square, you are not seeing any number here, but you know 1x, we don't write 1x, we only write x. So we don't write 1x square. What we write? X square. That means the coefficient here is what? 1. So coefficient of x square is 1. If I ask you what is the coefficient of x raised to the power 4 in this, you will say that it will be 0 because it is not present there. If I ask you what is the coefficient of x, so here coefficient of x is 3. No, it is not 3. I have told you this sign is carried along with it. So coefficient of x is what? Minus 3. So what we have understood for this, if I ask you what is the coefficient of x square, you will tell me 1. Coefficient of x, if I ask you what is coefficient of x, you will tell me minus 3. And constant term will be equal to 5. Clear? Clear? It's quite easy, huh? Got it? So till now we have discussed what are polynomials. Okay, how do you find out whether a given expression is a polynomial or not, and finding out the coefficients and all. Got it? So I hope if anyone has any doubt till now in this part, it will be clear. Now moving on to the next part, let us check whether below given expressions are polynomials or not. So now we need to check whether these expressions are polynomials or not. So I have told you, very easy to check. What we'll do? We will check the power of the variables, and the power of the variables has to be a whole number. So let us check one by one. In this term, what is the coefficient of x cube? 4. But we are not checking coefficients. We are checking what? Power. What is the power of x? 3. What is the power of x? 0. Remember, I have told you 9 into 1. So it can be written hidden variable. We have a hidden variable here, which is what? X raised to the power 0. Correct? So the power of the variable here is 3. Power of the variable here is 0. Both are whole numbers. So yes, it is a polynomial. Yes, it is a polynomial. Then 17x raised to the power 1.5 minus 2. What is the power of here variable here? Power of the variable here is 1.5. What is the power of the variable here? Power of the variable is 0. Is 1.5 a whole number? Nope. 1.5 is not a whole number. So we will say it is not a polynomial. Why? Because 1.5 is not a whole number. Correct? Then let's check the next part. 3 by 2 x square plus 5. Now see, what is the coefficient of x square here? 3 by 2. But do we need to check the coefficient? Have I ever told you that coefficient should be whole number? No. Coefficient could be anything. It can be rational number, it can be irrational number, no problem in that. Only thing is power of the variable we need to check. What is the power of the variable here? Power of the variable here is 2. What is the power of the variable here? Power of the variable here is 1. 2 and 1 both are whole numbers. Yes, both are whole numbers. So we will say yes, it will also be a polynomial. Here power of the variable is 5. Power of the variable here is 0. Now I have told you constant term also can be rational, irrational, anything. Only thing we need to think about is power of the variable, nothing else. So 7 by 2, be it 7 by 2, be it any irrational number, be it root 2 also, I don't care. What I need? Power of the variable. So I can say, sir, 7 by 2 can be written as 7 by 2 into 1, and I can write that as 7 by 2 into x raised to the power 0. So power of the variable here is 0, power of the variable here is 5. Both are whole numbers, so it is also a polynomial. Correct? Clear? Clear? I hope all of you are understanding. Let us solve the next part. Root x plus 5. Now see what happens when you have root x plus 5. Root x power we need to find out now. So all of you have studied in your previous chapter that root x means the power of the x is what? Half. Remember, if you have cube root of x, it means power of the x is 1 by 3. If you have 4 root of x, then it means power of x is to the power 1 by 4. Correct? So root x, so if I'll say, sir, what is the power of x here? Power of the x here is 1 by 2. What is the power of x here? Power of x here is 0. Is 1 by 2 a whole number? Is 1 by 2 a whole number? No. So we will say this is not a polynomial. Yup. Sure. Correct na yaar? Class, quite easy. Correct? Now let us go for the next example. Let's see what is the power of the variable here. Power of the variable here in this term will be 2. Power of the variable in that term will be 2. Root 3. What will be the power of variable in root 3? Is it half? Is it 0? What it is? It should be 0. Why? Because I have told, sir, the variable cannot be inside root. If the variable is inside root, that means power of the variable becomes half. Here, root 3's power is half. Root 3, if I write root 3, it means what? 3 raised to the power half. But 3 is not a variable for me. I can write this as into x raised to the power 0, because x raised to the power 0 is equal to what? 1. And root 3 into 1. What is root 3 into 1 only? Same root 3. So here also we have a hidden term which is what? X raised to the power 0. So power of the variable here is 2. Power of the variable here is what? 0. So again I will say this is also a polynomial. So just remember this class. Coefficients, constant terms, they can be rational number, they can be integer, fraction, irrational, anything. But the power of the variable has to be a whole number. That is the only concept. Got it? Now let's check it the next example. 2 by x square plus 7. 2 by x square plus 7. What is the power of the variable here and here? Here all of you can tell me power of the variable is 0. 7 into x raised to the power 0. What is the power of the variable here? Is it equal to 2? Is it equal to 2? Is it equal to 2? No. This power is not equal to 2. See, if I write 2x square, then you will say power of the variable is what? 2. But when I write 2 by x square, you cannot say, no sir, these two terms are same. Understood? These two terms are not same. 2 by x square, I can say if I change it, it will become 2 into x raised to the power minus 2. Yes or no? You remember this thing or not? When something you shift from denominator to numerator, its power becomes negative. So this 2 by x square form, this polynomial, this expression is in the form of 2x raised to the power minus 2 plus 7. Now what is the power of the variable here? Negative. What is the power of the variable here? 0. Is this a whole number? Nope. So I will say this will not be a polynomial. Remember this thing. X, all the variables, class, remember this thing, all the variables, whenever you are checking an expression is a polynomial or not, all the variables has to be in numerator. If the variables are in denominator, that means the power is negative and it will not be a polynomial. Clear? Now going for the next part, 3x square plus 3. What is the power of the variable here? 3. What is the power of the variable here? 0. 3 and 0 both are whole numbers, so yes, it is a polynomial. 5. What is the power of variable in 5? Very good. Power of the variable. See, all of you, we have done it till now. Power of the variable 5 into x raised to the power 0 I can write. So power of the variable here is 0. 0 is a whole number. Yes. So it will also be a polynomial. So I hope this all is clear to you. Correct? All of you have understood this part. Got it? Wherever you are feeling like you are not able to understand it properly, just take a screenshot. You will understand everything properly. Got it? Clear? Now there comes a term which is called degree of a polynomial. Degree of a polynomial. Sorry for this. Degree of a polynomial. Degree of a polynomial means what? That highest power in the polynomial is called degree of the polynomial. What is degree of a polynomial? Highest power of the variable. Highest power of the variable. Highest power of the variable in a polynomial. So suppose, for example, we will write, let us say 3x square plus 7x plus 3. Now first thing, whether we have to check whether it is a polynomial or not. So what is the power of the variable here? 2. What is the power of the variable here? 1. What is the power of the variable here? 0. Now tell me one thing, which out of the, see, all three are whole numbers, so we will say yes, it is a polynomial. Tell me out of these three, which is the highest power? Which is the highest power? 2. 2 is the highest power. So degree of this polynomial will be 2. Quite easy. Quite easy. You already know how to check the power. In that power, whatever is the highest, that will become degree of the polynomial. Clear, class? I hope you have understood. Now the next thing is classification of polynomials. How do we classify polynomials? Got it? So first classification is done on the basis of number of terms. All of you already have studied about number of terms, like terms, unlike terms in your grade 8. Understood? So suppose what are like terms, unlike terms? That suppose if I have x and if I have suppose x square, can I add these two? I'll say no, they cannot be added. Only x and 3x I can add, so which will become 4x. So like terms are the terms where variable is what? Variable is same. Variable part is same. Variable part is same. Variable part is same. And unlike term is what? Just opposite. Variable part is not same, or it is different, Understood? So terms we need to count. One more thing I can tell you. Suppose if I write, see, terms in a polynomial, terms can always be separated only by plus sign or minus sign. Suppose if I write 2 plus x, so how many terms do you see here? One term, two terms, so you will say two terms. If I write 2 into x, so you will not say there are two terms. 2 into x will give you 2x, which in the end is only what? One term. Understood? So only addition and subtraction sign can separate two terms. Only addition and subtraction sign can separate two terms. So we have understood terms, we have understood like terms and unlike terms as well. So now what is the classification? First term is monomial. Mono, as the name suggests, is 1. So the polynomial having only one term. For example, x cube, 5x raised to the power 4, 3 by 2 x raised to the power 7. All these only one term. There are only one term. So these all are called what? Monomials. Second thing, binomial. Bi, as the name suggests, means two unlike terms. Now see, the game here is what I have told. Here I have told key two unlike terms should be there. What is the meaning of unlike terms? See, terms I have told you are of two types: like terms, unlike terms. See what happens now. Now suppose if you have to add x and x, what you will get? 2x. Okay, now suppose if I give you an expression in this form, that 2x plus 3x. Now you will tell me, sir, you have told us that an addition sign can separate two terms. So there is one term, there is two terms, so there are two terms, so you will say it is binomial. But here comes the next part, is two unlike terms. That means that polynomial, all the terms should be unlike. That means no two terms should be added further. Can you add this 2x and 3x? Yes, I can add them. 5x. So this polynomial will be written in this form, 5x. So now it will become what? A monomial. So remember, two terms, whenever you are counting number of terms, all the term has to be unlike. All the term has to be unlike terms. Unlike term means what? Power of the variable should not be same. So for example, x cube plus x raised to the power 7. See, x cube power 3, x7 power 7. Different powers, that means variable part is not same, two unlike terms. 3x square minus 4x cube. One term, two term, both are unlike terms. 7 by 2x square minus 4. One term, two term, both are unlike. So this way we classify binomial. Remember this thing, if I write x square plus 5x square, is it a binomial? Nope, because these two terms are what? They are like terms. So I will say this will become in the end 6x square. So it will become what? Monomial. It will become monomial. Understood? Similarly, third part comes trinomial. Trinomial means having three unlike terms. All the three terms which are present there, they has to be unlike. For example, I can write x raised to the power 5 minus 3x cube plus 7. Three terms, all three terms are unlike. You cannot add any one of them. So this is called trinomial. Understood? For example, suppose let me give you a question. If I say that x cube minus 3x square plus 7x minus 9x square plus 2x plus 3x cube. This part, or wait, let me change it, plus 2x minus x cube minus x cube. This polynomial we have to find out it is a monomial or a binomial or a trinomial. So what we'll do, see, here we will first add all the like terms. We will do what? Add all the like terms. That means the terms which can be added, just add them. Okay, this is not the simplest form. So x cube and minus x cube, if I add x cube and minus x cube, these two will get cancelled. These two will get cancelled. X cube minus x cube will give you what? 0. Minus 3x square and minus 9x square will give you what? Minus 12x square. And 7x plus 2x will give you plus 9x. Now x square and x terms, can you add x square and x terms? No, they are unlike terms. So I'll say I cannot add these two. So I have two unlike terms. When you have two unlike terms, it will be a binomial. Understood, class? So whenever an expression is given, do not count the terms directly. First check whether there are terms which can be added or not. Then we will go for the part whether it is a binomial, trinomial, monomial, whatever it is. Understood? Clear? Now, so we have written the example. For monomial you can write x cube. For binomial you can write x square plus 7. And for trinomial you can write x cube minus 3x square plus x. Correct? So these are your three examples. Got it? We have already discussed this. Now the second classification is done on the basis of degree of the polynomials. What is degree? Degree we have already studied. It is what? Highest power of the variable. Highest power of the variable. Highest power of the variable. So degree of the polynomial, first part is called linear polynomial. What is linear polynomial? When polynomial whose degree is 1, that means a polynomial in which highest power of the variable is what? 1. Highest power of the variable is 1. That means if I write x plus 3, what is the power of the variable here? 0. What is the power of the variable here? 1. It is a polynomial because both the powers are whole numbers and highest power is 1. So these type of terms are called linear polynomials. That is why now do you remember in grade 8 you have learned a chapter linear equations. Why they were linear equations? Because when you solved that, only and only x was there. There were powers of those were not involved. Remember? So that is why they are called what? Linear polynomial. In higher grades you will get to know as well that why they are called linear only. Why they are not called square polynomials. Got it? Why we have named it linear polynomials, that also you will get to learn in higher grades. So it's very interesting, I'm telling you. So linear polynomial whose degree is 1. One more example, if you want to write, sir, 2x plus 3, or you can write 3x, anything, correct? So linear polynomial. Second type comes is quadratic polynomial. Quadratic polynomial. Polynomial whose degree is 2. Now degree is 2. See, when the degree is 1, the power of the variable can be either 1 or 0. If the power becomes 2, the power degree won't be 1, and we cannot go beyond 0 because the power has to be a whole number, correct? So when the degree is 2, the variable can have only this degree. Either the variable degree will be 2, or it can be 1, or it can be 0, correct? So I will say x square is a quadratic polynomial, yes. X square plus 3x is a quadratic polynomial, yes. X square plus 5 is a quadratic polynomial, yes. 3x square plus 7 is a quadratic polynomial, yes. 3x square minus 9x is a quadratic polynomial, yes. Okay, 3x square minus 3x cube is a quadratic polynomial, no, because degree is not 2. Now the degree has changed to what? 3. So when the degree changes to 3, what do we do? When the degree changes to 3, we call it a cubic polynomial. When the degree changes to 3, we call it a cubic polynomial. Correct? So polynomial whose degree is 3. So the what is the degree of variables can be? It can be either 3 or 2 or 1 or 0. Correct? For example, x cube minus 3x square plus 7x plus 10 minus 7x. Now see, here I am not counting the number of terms. First thing, either you can say, sir, either when you are counting the number of terms, we will go for monomial, binomial, trinomial. When we are checking the degree, we will go for linear, quadratic, cubic, like that. Here you can say, sir, this polynomial is a binomial. This is a binomial. Why? Because two unlike terms of degree 3. This you can say, correct? It is a binomial, two unlike terms, and degree is what? 3. So this polynomial is a binomial of degree 3, or you can say this is a cubic binomial. Cubic means power is 3 and 2 terms. Cubic binomial. So quite easy, correct? Just the two things we have understood. So quite till now what we have learned: linear power 1, or linear means degree 1, quadratic degree 2, cubic degree 3. For number of terms, 1 term monomial, 2 terms binomial, 3 terms trinomial. Now see, if the terms are more than 3, so there, see, you can say any specific name, that biquadratic or like that, but see, sorry, but after trinomial you can say pentanomial, or 5 terms pentanomial, so you can say all those, but we don't need to remember so many names. Rather than that, I'll say polynomial of degree 4, polynomial of degree 10, that is better. Because we are here not to mug things. I've told you, we are not here to mug things. Understood? So up to 3 terms we have named it. Rather, after that, it's not necessary. We have not found it necessary to name them all. Rather than that, what we are doing, we are, say, if there are names also, they are not in like huge, like they are not in the order the way we use it. So these are the terms which we generally use. Got it? These three. After that, if the degree is 4, degree is 4, we don't call it say biquadratic or like that. We will simply say polynomial of degree 4. Got it? Some people will say biquadratic or all, but we generally go for degree 4. Got it? So this is what we need to remember, these three things. Now, interesting thing. So I think we have already written one example of each type, correct? Now, interesting thing is constant polynomial. Constant polynomial is polynomial whose degree is 0. Polynomial whose degree is 0. Now tell me this thing. See, degree 0 means when the degree was 1, you told me, sir, that means the variable can have either 1 or 0. These two powers are permissible. When the degree is 2, that means the variable power can be 2 or it can be 1 and it can be 0 maximum or minimum. When the power is 3, it can be 3, 2, 1, 0. 3, 2, 1, 0. When I'm telling you that degree is 0, that means highest power of the variable is what? 0 only, and you cannot go beyond 0 because after that negative number starts and that is not a whole number, correct? So that means the degree of the variable will be 0. So can you tell me what kind of numbers will be an example of this part? Can you tell me what kind of examples will you get for constant polynomial? It is very important for me. What kind of number you will be getting for constant polynomials? Yes, you have learned today's session, you have learned. Remember this thing or not? 5 into x raised to the power 0. So when you write 5 into x raised to the power 0, it will become what? 5 into 1, which is 5. 6 minus 3 minus 2 root 2 pi, any constant you are writing here. I can write it as, suppose minus 3, I can write as minus 3 into x raised to the power 0. So minus 3 into 1, which is what? Minus 3 only. So these numbers are constant polynomials, correct? So we have done root 2, I can write as root 2 x raised to the power 0, correct? 3 I can write as 3 into x raised to the power 0. 5 I can write as 5 into x raised to the power 0. Now 0 I can write as 0 into x raised to the power 0. So this will give you 2 root 2, this will give you 3, this will give you 5 again, this will give you 0, correct? So you will say they all are constant polynomial. But now comes the twist. Okay, see what the twist is, that a student told me, sir, okay, tell me this thing, if you write 2 into x raised to the power 0, you will get 2. I said yes, correct. If you write 2 into x, you will get 2. You will get 2x. I'll say yes, correct. This is also correct. If you write 2 into x square, you will get 2x square. I'll say yes, this is also correct. I'll say 2 into x cube, you will get 2x cube. Yes, all is correct. So now he is saying, sir, that means just by looking at this, I can tell what is the variable power. If I write 2x raised to the power 7, that means you can say, sir, it is multiplied. 2 is multiplied with what? Power of x is 7. If you write 2 into x raised to the power 9, it means 2 is multiplied with what? 9 power of x raised to the power 9. So just by looking at this product, I can find out what is the multiplication here. For 0, sir, you are telling me 0. So if you write 0 into x raised to the power 0, you are getting 0. 0 into x, you are getting 0. 0 into x square, you are getting 0. 0 into x cube, you are getting 0. 0 into x raised to the power 4, you are getting 0. So now tell me, sir, if I write a 0, this 0 is whether this one or this one or this one or this one or this one. Which 0 is it? Understood? What is the problem here? With other numbers it is perfectly all right. Any other number you can pick. Suppose if you want to pick any other number, let us say, if you want to pick any other number, let us take a negative number or a negative fraction, let us, or negative, say rational number. If I take minus 3 by 2 into x raised to the power 0, I will get minus 3 by 2. Minus 3 by 2 into x, if I'll do, I will get minus 3 by 2x. Minus 3 by 2 into x square, I'll getting minus 3 by 2 x square. So here when I look at the product, I can tell what is the power of the variable. If I give minus 3 by 2 x raised to the power 10, that means you know, sir, minus 3 by 2 is multiplied with x raised to the power 10. Suppose take an irrational number also, root 2. If I multiply with x raised to the power 0, you will get root 2. If I multiply it with x, you will get root 2x. If I multiply root 2 with x square, you will get root 2 x square. Correct? So if I write root 2 x raised to the power 5, it means root 2 is multiplied with what? X raised to the power 5. But sir, when you write 0, how will I know whether it is x raised to the power 0? When you write 0, how will I know whether it is x raised to the power 0 or it is multiplied with x, or it is multiplied with x square, x cube, x raised to the power 4, x raised to the power 5, x raised to the power 6? What will I choose? Because 0 multiplied with anything is 0. So now it is a problem. So now what do we do? So what do we do here? Okay, we do not include 0 in constant polynomials. So this is the main thing. We do not include 0 in constant polynomials. All other numbers, okay, all numbers, or let me say all real numbers. All of you have studied real numbers. What are real numbers? Rational number plus irrational number. Suppose I have rational numbers, correct, and I have irrational number. This is all of you have studied in your first chapter, correct? So when these two numbers, if you put it in a bag, in a big bag, so this whole bag will be the bag of real numbers. Okay, so all real numbers are, or all real numbers except what? 0 are constant polynomials. All real numbers are, or all real numbers except 0 are constant polynomials. We are not including 0 in constant polynomials. Why? Because I have told you already, because we don't know whether this 0 is multiplied with x raised to the power 0 or x square or x cube or x raised to the power 4. We don't know. So we don't know, na? If I write root 2, you can tell me, sir, it is x to the power 0. But if I write 0, how will you know it is 0 into x raised to the power 0 only? It can be 0 into x, it can be 0 into x raised to the power 10 also. In all these cases, you will get 0 only. Got it? So we cannot be sure. So we told what? 0 is not included in constant polynomial. So all real numbers except 0, all real numbers except 0 are called constant polynomials. Understood? So this is a quiz class. Quickly tell me your answer for this part. Can we say that all real numbers are constant polynomials? Can we say all real numbers are constant polynomials? Quick class, 10 seconds time I'm giving you. Quick, all of you comment your answers, comment your answers, comment your answers. Comment your answers. Yes, no, all of you. Can we say that all the real numbers are constant polynomials? Okay, let us check the answer. What is the answer? Tell me, what should be the answer? No, all the real numbers are not constant polynomials. Just now we have told all real numbers except 0 are constant polynomials. So the answer will be no, not all real numbers. All real numbers except 0 are constant polynomials. Correct? So all non-zero real number, non-zero means the number should not be 0, or real number except 0 are constant polynomials. Correct? Clear? 0, so what is 0? 0 is called a zero polynomial. So remember this thing, 0 is not a constant polynomial. We call 0 what? A zero polynomial. 0 is what? A zero polynomial. Got it? 0 is not a constant polynomial. So sir, if you are saying 0 is a zero polynomial, still okay, you have named it different, but my answer is not there, sir. If you write 0, What should I call it? 0 into x raised to the power 0, or 0 into x, or 0 into x square, or 0 into x cube, or 0 into x raised to the power 10, or 0 into x raised to the power 100. What, sir? Which one should I pick out of all these? All are correct. So I'll say, see student, I got your point. All are correct. All are correct. The same point. So we cannot say which one out of this is it. So what we told, that the degree of a zero polynomial is not defined. Remember this thing, class. It is very important. First thing, all real numbers are constant polynomials? No. All real numbers except 0 are constant polynomials. Got it? All real numbers are constant polynomial? No. 0 is a constant polynomial? No. 0 is a zero polynomial. Degree of a zero polynomial is 0. Many will make this mistake. Degree of a zero polynomial is 0. No. Degree of a zero polynomial is not defined. Degree of a constant polynomial is what? Degree of a constant polynomial is what? 0. Degree of a zero polynomial is not defined. Got it? So I hope all of you have enjoyed this session today. Yeah, correct? So see, this is our part. So I hope you have liked my session today. Okay, so this is just a glimpse of what we are doing here. Got it? See, we frame the chapter very carefully, that each term will go into your mind, and see, it should be learning with fun. So I hope you had fun today as well. Correct? So this is we Vedantu will do. We are working hard for, so that all the concepts, all the typical or the easy to tough, all the concepts go through you and you understand them one by one carefully, and you just nail your exams. That is what our goal is. Got it? So that is what our goal is. So Vedantu, we have here subject expert faculties, 24/7 doubt solving support. See, this even your schools won't be providing 24/7 doubt solving support. Academic mentors will be there who will be solving your doubts anytime. Academic mentors, us, anytime you have your doubt, you post your doubt to us, we will solve it. Got it? So this is what you get if you join with us Vedantu. Organized content and sheet, because practice is the most important. Practice makes a man perfect. So sheets are given to you so that you practice more and you become perfect. You reach the level of perfection. Understood, class? So this is what we do at Vedantu. If you want, if you like the way we teach, if you love the way we teach, if you understood these things properly, so register for this young Vedantu Young Master course. This is for 2 years course for class 9th and 10th. This is 2 years course for class 9th and 10th. This is the course price, but if you register it now, you are getting at this price. This is the discount lightning price. Correct? This is the lightning price, and this is the link to register for this course. Got it? So I hope all of you have enjoyed this session. I enjoyed this session really well. Okay, so goodbye, sweet dreams, see you, sabba khair, everything. We'll see you in the next session. Over and out. Okay, class, goodbye.